Imagine standing at the edge of everything you know and looking out into a darkness so vast, so incomprehensibly deep, that the light reaching your eyes left its source before the Earth even existed. Now imagine that darkness is not empty. It is alive with structure, a web, a cosmic architecture so enormous, so intricate, that every galaxy, every star, every atom in your body is part of it. That web has now been mapped, and what scientists have found will change how you see the universe forever. For most of human history, we looked up at the night sky and saw scattered points of light, chaos, randomness, a universe with no shape, no pattern. But over the last few decades, something extraordinary has been revealed. The universe is not random at all. It is organized on a scale so grand it almost defies imagination, into what astronomers call the cosmic web. So what exactly is the cosmic web? Think of it this way. Take a spider's web, glistening with morning dew, each strand connecting node after node. Now scale that up, not by thousands, not by millions, but by billions of light years. The strands of the cosmic web are called filaments, and they are made of gas, dark matter, and the gravitational forces that stretch across the universe like the bones of some impossible skeleton. Where those filaments intersect, you find galaxy clusters, the densest, most luminous objects in the observable universe, and between them, vast, hollow voids, regions of space so empty they make intergalactic space look crowded. This structure was first theorized in the 1980s when early computer simulations began showing something remarkable. When scientists fed the laws of physics into their models and let time run forward from the Big Bang, galaxies did not scatter randomly. They formed along invisible scaffolding. Threads of dark matter pulled ordinary matter along with them, and over hundreds of millions of years, the universe stitched itself into this vast interconnected web. But theory is one thing, seeing it is another. That is where some of the most ambitious scientific projects in human history come in. The Sloan Digital Sky Survey, launched in the year 2000, spent over a decade mapping the positions of over 1 million galaxies in 3 dimensions. And when astronomers plotted those positions in space, what emerged was breathtaking. There it was, not chaos, a web. Shimmering filaments of galaxy clusters stretching for hundreds of millions of light years, surrounding dark, empty voids. The universe had a face, and it was unlike anything we had ever imagined. More recently, the Dark Energy Spectroscopic Instrument, known as DESI, has pushed this mapping to an entirely new level. In just its first year of operation, DESI cataloged the positions of over 6 million galaxies, and that number is climbing toward 40 million.
These observations stretch back over 11 billion years of cosmic history, giving us not just a map of the universe as it is today, but a time-lapse of how the cosmic web has grown and evolved since nearly the dawn of time itself. Now here is the part that truly staggers the mind. The filaments of the cosmic web are not just made of the galaxies we can see. The vast majority of the material in those filaments is dark matter, a substance we cannot directly observe, cannot touch, and do not yet fully understand. It emits no light, it absorbs no light. We know it exists only because of its gravitational fingerprint on everything around it. And yet, dark matter makes up roughly 27% of the entire universe. It is the invisible skeleton upon which all visible matter hangs. Without it, there would be no filaments, no clusters, no galaxies, no stars, no us. Interwoven with the filaments is another invisible force, even more mysterious: dark energy. It makes up 68% of the universe, and it is driving everything apart. The cosmic web is not static. It is stretching, expanding. The voids are growing larger, and the filaments, though still connected, are slowly being pulled to their limits. In the far future, billions of years from now, the web will thin. Galaxies will drift beyond each other's sight. The universe will grow cold and dark and silent. But we are not there yet. Right now, we live in a moment of extraordinary cosmic richness. And here is the perspective shift that I want you to sit with for a moment. Our own Milky Way galaxy is not floating freely in empty space. It is embedded in a filament of the cosmic web, part of a structure called the Laniakea supercluster, which stretches 500 million light-years across and contains the mass of 100 million billion suns. 500 million light-years. If you traveled at the speed of light,
It would take you 500 million years just to cross this one region of the web. And Laniakea is just one tiny knot in a structure that contains hundreds of billions of such superclusters. You are not a speck of dust in a meaningless void. You are a thread in a tapestry that spans the entire observable universe. What makes this mapping so significant is not just the beauty of it, though the beauty is real and profound. The cosmic web is a Rosetta Stone for cosmology. By studying how its filaments are distributed, how the voids have grown, how galaxy clusters have evolved over billions of years, scientists can test and refine their models of dark matter, dark energy, and the very geometry of the universe itself. The map is not just a picture, it is a time machine, a gravitational fingerprint, a record of everything the universe has done since the moment of its birth. And the map is still being drawn.
Projects like the Euclid Space Telescope, launched in 2023, and the upcoming Vera Rubin Observatory are set to extend our view even further, mapping the cosmic web across even greater distances and deeper stretches of time. Each new data point is another brushstroke on the most ambitious portrait ever painted. We are living in the golden age of cosmology, a time when questions that once seemed purely philosophical, questions about the shape of the universe, about what it is made of, about where it is going, are being answered not with speculation, but with data, with observation, with maps. The universe has structure, it has shape, it has a story, and we are only just beginning to read it. If this journey through the cosmic web left you with that electric feeling of wonder, that sense that the universe is so much grander than you imagined, then hit that like button and make sure you are subscribed so you never miss a moment of exploration. Drop a comment below and tell me this: does the idea of the cosmic web make you feel small, or does it make you feel connected? I want to know. And stay tuned, because next time we are diving into the most violent events in the known universe, the collisions of galaxy clusters, where the cosmic web tears itself apart and rebuilds. You will not want to miss it.